Okay, moving on with problem number 4. This directions here say solve the system using substitution. Since it requires that you use substitution, then you must use that method in order to receive full credit. Notice that substitution needs to have one of the equations solved for one of the variables. The second equation is already solved for y, so I'm going to take this x plus 3 value and substitute it into the first equation where the y is. So that would give me 3x plus x minus 3 when I replace the y with x minus 3 equals 7. Now that's just a simple equation with one unknown here, so collect your like terms. I get 4x equals 7. We're going to add the 3 to both sides, so 4x equals 10. Divide by 4 and simplify the fraction. You get x equals 5 over 2, 5 halves. Okay, now what we want to do is take that value and substitute into one of the equations. It doesn't matter which one you choose. I'm going to choose to substitute it into the one that's already solved for y. So I get y equals 5 halves minus 3. And when you do that arithmetic, you get negative 1 half. Remember, you're not finished until you've written your answer as a point. Remember that the answer to a system of equations is the point at which they intersect, and that would be the point 5 halves, negative 1 half. The x should come first, the y should be second. Number 5, they've also required the directions saying solve the system using substitution. So neither of the equations is solved for y or x, so you need to pick one of the equations and solve it for x or y. I'm going to pick this bottom equation and solve it for x so that I no longer have to deal with a negative here. So I am going to replace and add the y to both sides. So I'm going to get x equals y plus 6 when you add y to both sides. Now I'm going to take this value, y plus 6, that equals x, and replace it in that first equation where the x is. So that's going to be y plus 6 plus y equals 1. After the substitution step, you should only have the single variable, meaning all y's or all x's. And you'll notice that I only have y's, so I'm on the right path. Solve this equation. Collect your like terms, so I get y plus y is 2y. Subtract 6, so you get 2y equals negative 5. Divide by 2, and y equals negative 5 halves. To find x, let's substitute into this equation. You could substitute it into either one, but this one's already solved x equals, so I'm going to substitute it there. So negative 5 halves plus 6, that means x equals 7 halves. Again, you're not finished until you write your answer as a point, x first, so x comma y, and there's the solution to that system. Alright, the directions for 6 through 9 say to solve the system using elimination. Remember, the methods of elimination are addition, subtraction, or multiplication. Okay, so the first thing you want to do is decide which of these three methods would work for the system of equations that you have. Addition works if one of the sets of coefficients for the variables are opposites. So you'll notice here that the x's are not opposites, they're the same. So addition will not work. If I add these two equations, neither variable, x or y, would eliminate. So addition is not the method for this system. Subtraction is used when the coefficients of one of the variables are the same, which you'll notice that is the case here. Since they're both 2x, if I use the subtraction technique, which says change the signs of every term in the second equation and then use addition. Notice how now the coefficient for the variable x are indeed opposites, which means they will eliminate or cancel. I can now collect my like terms here. Negative 5y equals negative 5. Divide by negative 5, and the y value is positive 1. I still need the x value, so plug into any of the equations. I'm going to plug into the bottom equation, original equation, so that's going to be 2x plus 4 times 1 equals 10. 2x plus 4 equals 10. Subtract 4, you get 2x equals 6. Divide, and the x value is 3. Remember to write your answer as a coordinate point, 3, 1. Okay, continuing on with the elimination technique, we look at these two equations to decide if addition will work. Well, neither of the coefficients for the x or the y are opposites of each other, so addition will not work. So let's see if subtraction will work. Well, no, because none of the coefficients are going to be the same, so subtraction doesn't work. The only method for elimination that will work for this system of equations will be multiplication. And you have several options here. I'm going to choose to multiply the bottom equation by -5. And the reason I choose -5 is so that I have a -5x here that I will then add with a positive 5x and they would eliminate. So I have to multiply the entire equation by -5. So I'm going to bring down that first equation. I'm not making any changes to it. And I will multiply the second equation through by -5. And that gives me -5x minus 15y equals -50. At this point, after the multiplication, you should be able to use addition, and one of the variables should eliminate. So here, the 5x and the -5x do eliminate, and I get -17y equals -34. Divide by -17 to get that y is a positive 2. I still need the x value, so I'm going to substitute that into this bottom equation, the original equation, to find x. So x plus 3 times 2, replacing the y with the 2, equals 10. That's x plus 6 equals 10. Subtract the 6, and the x value is 4. Once again, make sure that your answer is written as a coordinate point, 4, 2. All right, problem number 8. We're still trying to use elimination, so we still need to use whether we want addition, subtraction, or multiplication, but the problem is too messy to decide at the way it looks. I want to get rid of the fractions. So multiply this top equation by its LCD, which would be 6, and multiply the bottom equation by its LCD, which would be 10. So when I do that, 2 goes into 6 3 times, so 3x. 3 goes into 6 2 times, so minus 2y. And 1 times 6 is 6. Okay, let's do the same thing with the bottom using its LCD, which is 10. So when I do that multiplication, I'm going to get 2x plus 5y equals -10. Now this is a much easier problem to look at. Now I can choose whether I want to get rid of the x's or y's, and I need to choose what method of elimination will work. Well, addition or subtraction, neither one of them will work because none of the coefficients of the x or y are opposites or the same. So I am going to choose to get rid of the y's, and I do that because they're already opposite signs. So I'm going to multiply the top equation by 5 and the bottom equation by 2. Okay, so I'm going to write my new set of equations here. I get 15x minus 10y equals 30. Notice how I multiplied each and every term by that 5. Now multiply the bottom equation by 2. I get 4x plus 10y equals -20. Use addition. These eliminate. I get 19x equals 10. Divide, and x is 10 over 19. Substitute in. I would pick one of these. I picked the top one. 3 times 10/19 minus 2y equals 6. And this gives me 30/19 minus 2y equals 6. Subtract 30/19 and you get 84/19. Divide by -2, and y is -42/19. Use your calculator to confirm that arithmetic. And the answer in point form, 10/19 and -42/19.